at these ones. And what about the 8 and 9?
Oh, I haven't done those yet.
Okay, let's do those first and we'll go back up. I want to make sure you get your word problems. Well, there's only one. Okay, good. Is there more? Okay. Well, I guess there's one more here, number 7. Okay. Okay, there. All right, let's do 8 first. Is that okay? And
Yeah.
all right. Okay, number 8. Which is an equation for the nth term of the sequence? Okay. So I'll let you think about it first. What do you think? How would you go about it?
I'll start, like, I would try to solve it with, like, the original arithmetic sequence.
Okay. Okay. Like how?
So I'll probably do AN equals A1, and then, like, go on from there. Like,
Oh, I see. I see. Good job. I prefer that you do it that way. The reason why is because you probably get practice doing it rather than testing these numbers out. Get it? Like if you could, some student would do that, possibly because they don't remember or they didn't practice enough, right? You can imagine. But do you know what I mean about testing it? Now there's nothing wrong with this. In the future, if there's something that you don't remember, you understand the concept and you understand what to do, what will happen, you can, do that. Plug in, like plug in 12, 15, 18 and test them out. For example, 18 will be the third one. That means a sub n, 3, for example, if you test it for the f, a sub 3 equals 3 times 3 plus 9. It better be 18, for example. But that can be a bit deceiving because you may have to test all of it. That's a lot of time, right? Spending. Okay, tell me. I'll do it with you. I'll let you go first. What are you gonna do? So I think you mentioned a sub 1. What is that?
So it's the first
Okay,
number in the
it's 12.
sequence.
Okay, but tell me the formula for the arithmetic sequence. So you have it down.
Yeah, so it's AN equals A1 plus, then in parentheses,
Mm-hmm.
I think it, and
Minus 1.
minus 1,
Okay, and what?
and then times it by D.
Times it by d. Okay, how confident are you with this? You seem to slow down a little bit. Huh? What do you think? How confident are you?
I think I'm, like, okay, confident.
Good, it is. Correct. I just want to make sure because why can't my box, let me see. I want to do my box straight. Yeah, you got it. Look at that. I can do this. I can make it even, wait, how about perfectly rectangular? I remember I was able to do it. I forgot. Anyway, that looks good enough. All right, let's continue. Let's do a sub n equals 12 plus, what's n again? Just n. If they say n, right? Right?
Yeah.
Okay, minus 1. And what is d?
D is the common, like,
Difference.
difference.
What is it?
It's 3.
Yes, and you could see the rest of it also, right? The latter, subtract the prior. 15 minus 12, 18 minus 15, 21 minus 18, so forth. And so, they're all going to give you 3. That's good. That's good. Let's continue. Distribute, right? Yes. So 12 plus 3n minus 3. And we want to write the 3n first. You can tell. And then 12 minus 3, that would be 9. It's right, exactly the first one, F. Very good. All righty. You okay with that?
Yeah.
In the next one. Number 9. What is the 12th term in the sequence? So they're still talking about these numbers, okay? Right? So what do you think? How do we do it?
So is it A12 equals 12?
Okay, nothing wrong with what you're about to do. Do you want to do it differently, a little faster? There's nothing wrong with what you're about to do, but what do you think?
It's fine if I could do it a little faster.
Wait, how? I'm not saying much, but do you want to think about it? How could you do it faster?
Uh,
Okay, I'll tell you. Isn't this already the formula for it? Right? You don't have to do it from scratch. You could. It'll be the same. You know what I mean? Wait, think about it, right? You could literally just plug it in. Do you understand it? Yeah, so this is the a sub n right here that you can use because number 8 and number 9, they're related, right? It says so that, hey, this is the exact same sequence, right? Okay. I think you got this, right? Now, okay, on the test, you may be right. You're likely going to have to do it from scratch. They're not going to give you one related. Is that okay? Okay,
yeah.
so yeah, you're on track. I mean, yeah, on the test, they're likely going to be independent of each other. They're going to be different, different sequence, different. Yeah. Okay. 30. What is that? 36 plus 9. Okay. What we got? 45. There you go. C. You okay?
Yeah.
Okay. All right. Let me look at your. We can do it from scratch. Let's look at from the top. I was focusing on the graph, but let me look at the top from the top. Okay. Where does the graph of y equals negative 3x minus 18 intersect the x-axis? Okay. So I don't see the work, but how did you do it? You could even mentally do it, I'll bet. But how would you do it? How did you get that letter? Is that C? Yeah, okay. How do you do it?
So let me think.
I'll brush up your memory here. You always want to visualize the graph. This will help you recall it any time in the future. So here's the XY axis, right? The Cartesian plane. X-intercept, right? Is that what they're asking? Yeah, it's telling you that, hey, we're intersecting the x-axis, therefore it's x-intercept. So let's pretend it's right there. So I recommend you actually learn to do this like on your own, like sketch it out and kind of draw a line through x-axis or y-axis, depending on what they're asking. So this one is implied x-axis. It's the way they coin it, intersect the x-axis. So x-intercept. So if you were to actually label that point, you always know one number for sure. Y will be 0, right? You see it? Y has to be 0. And X, it depends. I did not scale this X axis. Therefore, I need to know what that is right there, the X. That means you solve for X when your Y is 0. Get it?
Yeah.
Try to think about that. Okay, this is so easy in the future. You never have to memorize anything. You just sketch it out, like the y-axis, y-intercept right there. If you do y-intercept, right, your x will always be 0, and your y will be what you're solving for. It'll be like your y. Get it? Like it looks fancy, but I think you understand. You don't have to put X in there in the box or Y. You know that, hey, it's missing. You're trying to get it, whatever. So that means, here we go. Do the math. You can mentally do it, I'll bet. So when you do x-intercept, your Y must be 0. You can think opposite if you want. You want to memorize it, but I don't think you need to do that because sometimes you have much to deal with later concepts. So therefore, sketch it out if you're not sure. You get it right away. I think you understood, how I come up with that, right? Yeah. So you can do this on your own. I promise it helps. Or you don't have to be perfect drawing it like that. Okay. So Y equals 0. Okay. Then I'm working upward. Okay. Add both sides by 3x. That's 3x. So I'm going to get 3x equals negative 18, right? And then divide both sides by 3. And so x equals negative 6. And don't forget, your y is 0, your x is negative 6. There you go back to the graph again. Or, here's the reasoning. You put the y being 0, therefore it better be 0 there at the coordinate. So therefore the answer is D. I don't know what you put there. If it's not B, let me see.
I think I make.
Yeah, you got to flip flop. Yeah. So that's why, yes, that's why you want to think about the sketching. Get it? You got to think about the sketching. This is going to save your butt for the future math. Okay. So I hope you're okay. Like, hey, the coordinate on the axis and all that, hey, your axis. Hey, 1, 0, 2, 0, 3, 0, 4, 0. This is just an example. Okay. Negative 1, 0, and so forth. Okay. So it's going to be D. I go forward. Okay. All right, let me see. All right. Let me see number 2. What is your reasoning here? Okay, 2. Tickets to see a movie cost $5 for children and $8 for adults. And here's the equation. 5x plus 8y equals 80. Now, before I read on, what is x and what is y? Let's see how much you've got down. What is x and what is y? Oh, they tell you that on the bottom. Don't read on. The reason why I asked you that ahead of time is because in the future, you have to come up with this equation on your own. I'm not kidding. For a system of equations. Okay. So you're going to do this on your own, but they tell you moving on. Okay. Anyway, I saw it right here. So I was asking you, okay. Okay. 5x plus y, plus x plus 8y equals 80 represents the number of children x and adults y who can see, the movie with $80. So they describe all the terms here. If no adults see the movie, okay, how many children can see the movie with $80? What does that mean?
So like how many kids can see the movie?
Yeah, but how would you solve it?
So I would put 0 in for y.
Yes, that's it. You got it. So 0 for y here. That means 8 times 0. This is like the x-intercept. Get it? But they're doing a story based anyway out of it. So it's not just graphing anymore. You can actually, have word problems relating to x-intercept. So anyway, so it's going to be, this is your objective here. That's what you said. So it's going to be 0 here. It's going to go to 0. Therefore, 5x equals 80. Then divide both sides by 5. X equals, what is that? 5 can go into 8 one time, and then the 3 16 times, right? See? Okay, so it's J is your answer. Good job. Right on. I see your J right there. Very good. 3. Find the line through these 2 points. Now, before I move on, do you have anything online that you have to do, that you have to finish? Or you're okay? Good. I'm sure there's practice, but I think it's best to, look over this because it's more immediate. I know that you still have till Friday. Will you have another worksheet or additional review sheet.
Uh, I think we probably will get another review on
Okay.
Thursday.
Okay. Good. 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 Very happy because because you may have because the time between now and then, that's a bit far apart. Yeah,
Yeah.
that means you likely gonna have another one. Okay. Anyway, good. Line through 2 points here, and you have to find the slope. Do you remember how to do that? Okay, you can do this right here. You raise that little. That's pretty cool. Yeah, how do you do that? Do you remember the
So,
formula? Or you can tell me how to go ahead and set it up right away. Number 3. Oh,
so you you minus the 3 by -1.
okay. Where do you put it?
Like in a fraction, you put it under.
Okay.
Like
3 minus -1. Okay, good. What's at the top?
yeah, and then on the top it's 7 minus 4.
7 minus 4. Very good. So just to remind you the formula, this could be x sub 1, x sub 1, y sub 1, x sub 2, y sub 2. And you can use the formula that's either one, but you have to make sure that you do 1, 1, 2, 2 like this. For example, you can have y sub 1 minus y sub 2, x sub 1 minus x sub 2. So this is one variant. Another one is going to be, you, you use this one. No problem. I did that too with you last time. And without realizing it, I was writing it, but I said, but I did mention that, hey, you can do ones or twos, but if you do twos, you better do 2 for the x. For example, y sub 2, you have to make sure that the bottom is x sub 2 that you start off. Is that okay?
Yeah.
So, and then this will be your y sub 1 and x sub 1. Now, sometimes this is a bit much to memorize. I understand that. So, but you do remember the pattern of subtracting them. So I'm glad, at least, But I think trust me, I promise these two will be like nothing. You'll remember it because you'll do more of it a lot in the future and the rest of the school year even. You come back to it. And what I mean is that you're going to do it every single day, a week or anything. You're going to come back to them again and again and next year too. Okay, continue on. Yeah, you got this. It's going to be 3 over, it'll be plus here, right? So it'll be 3 over 4. So 3/4. Yeah. Now, if you don't, if you're not sure if you can do either one, try it. Try the other way around. We did that. I don't know if you realize it. We did that. You can do the other, subtract the other way. You'll get the same answer. There'll be negatives that kind of cancel each other out, like the numerator, denominator, and, you'll see. But yeah, for practice, you can always do it. But anyway, it's B. Good. All right. Very good. It's B. All right. 4. A line through that, and you can eye it. You can see that the numerator will be. Could you see it? What subtract what in the numerator? For 4. Sorry.
So in the numerator it would be 2 minus 2.
So it's 0 divided by some number on the bottom,
Yeah.
right? What is the answer? What is 0 divided by a number?
Undefined.
You sure?
Wait. No. Is it 0?
Okay, yeah. Well, let's talk about it. You put h. Okay, yes. The numerator being 0 divided by any number will always be 0. But the other way around, it's not. But yeah, the other way around is, it's like, I guess a special case, but in math, it's like a common thing, especially when you get up there, right? So yeah, if you have a number on top and 0 in the denominator on the bottom, this is undefined.
Mm-hmm.
But you can think of it this way. I don't remember the memory technique. It's like something on top over a one uni cycle, like a wheel. They fall off. Imagine that they're not that good. Whoever riding this is like foot topple over. So that's kind of bad. It looks scary. How about that? You can think of it that way. Therefore, it's undefined. You can think of it like, hey, it's unusual. Get it? That's it. But this is like it's nothing. It's like a head of somebody or a sun rising from a horizon. That thing, yeah. So this looks fine. It looks like a person. This one looks like a unicycle, and you can topple off. You don't know how to ride it. Like you can flip. Think about that. It's pretty cool. It's like a memory technique. Did I come up with that? I might have come up with that one just now. I'm looking at it, or I might have seen it somewhere. Maybe I'll Google it and I'll see. I'll bet I actually the first one who actually thought of it. But you see that? It's like a visualization of it, like a mnemonic, a memory technique. Yeah, if you're riding a unicycle and you don't know how to do it, you can flip, you can fall. Therefore, something bad about it could happen. Therefore, it's undefined. But in math, yeah, it's not a big deal. It's something, yeah, you see it. Anyway, is that okay? Think about it. That's like a pretty cool memory technique. Yeah, the numerator 0 looks like a face or somebody on top there. That's fine. That's like you see it, a cartoon. But this is like a unicycle. No good. No good. Something gonna happen. Something bad. So undefined. Anyway, I don't know if that makes sense, but okay. What about a vertical line? Yeah, this is actually not quite a well-written problem. Yeah, what does that mean? You know what? A vertical line. What does that mean? Okay, wait. I see. You have to actually come back up here. All right, come back up here. So the instruction says, hey, from 3 to 5, find the slope of each line described. A vertical line. What is the slope of a vertical line? So how do you know it's, what did you put, D? How do you know it's undefined? A vertical line. Like that or like this? So how do you know? It's correct, by the way, but how do you know?
Because
Okay, no, you could have heard it from your teacher. You could have heard it from somewhere. So this is actually you can remember it. I mean, but the reason why is very simple. Watch, I'll make up 2 points. I'll put it near each other, I guess. So this point, I'll go ahead. It makes sense here. Watch. At least you get to see the reason. In math, if you understand it, you tend to actually like how it came about, and you can derive it in the future. It will help you recall or make up something on your own and test it and see whether it's right or wrong, or whatever the problem is. Say, for example, at this point, let's just say this is going to be 2. Okay, pretend this is 2 for the x. So 2 comma 2 and then 2 comma 1. Is that okay? Like those 2 points. So, okay, if you do the slope formula, right, or you subtract them, your y's on top, right? Your y's on top, it'll be 2 minus 1 or 1 minus 2, and then 2 minus 2. You see it? Do you understand that? You sure?
yeah.
Yeah, the denominator right here, your x are in the denominator, you subtract them. Therefore, it's 0 and denominator is undefined. It's a number on top, it's 1. That's it. Yeah, so if you need to, help your friend or explain it to someone, there you go. Okay, but you might have heard that from somewhere, your teacher, likely. Okay, that's good. Now, 6. Which graph? Oh, what about horizontal line? Let's say, I don't see one asking that. What about number 5.2? Number 5.2 ask a horizontal line. Because this could be on the test. What would the slope be? Horizontal. I don't know why I spelled that. Horizontal. So what if it's a horizontal line? What
It
would
would be 0.
Yes, the numerator would, yeah. Let me do it quickly, okay? But I think you could kind of imagine why, but okay, I'll do it anyway here. Yeah, it would be 0. Here's why. All right, have a look. I'll go ahead and do a point here, another point here. Here's your horizontal line. And let's just say this is 1, this is 2. I keep going back to 1 and 2, man. I'm sorry. Okay, then I'll do it different. I'll do this would be 2 and this would be 4 and this would be 2 and this would be 4. But this still like, oh man. Okay, so sorry. Let me do 4 comma 4. This is going to be 2 comma 4. Okay, so have a look. Okay, have a look. So if you subtract them, help me subtract them. Do a slope form. Use a slope formula for me.
Okay, so it would be 2 minus 4, and then 4 minus 4.
Okay, 2 minus 4 where?
In the denominator.
Okay, and then the numerator.
4 minus 4.
That's why you get your 0 on top, and this is fine. Okay, that's why it's going to be 0. So I made that up just in case, because on the test you may get one. All right, 6. Okay, how do you know the slope is negative 3? Which one?
So I put G because so the run is 6, and then like the rise is 2, so it's 2 over 6, and then simplify that.
Okay, so let me go again here. How do you come up with the 6 again? How do you come up with the 2? Go again. Sorry. The reason yeah. I have to say it's not correct, but I wanna ask you how you got those numbers again. One more time. I'm sorry. I apologize. So
Because so it's like so we learned in class that it's like
rise and run.
Yeah, we learned rise and run.
Okay, where you want to start? Do you want to start here, or where do you want to start to rise and to run it?
I'll start there where you put it.
Okay, and how you gonna rise it? Rise 2? Is that how you want to do it?
Yeah.
Okay. So let me put a form of fraction. Rise 2, is it numerator or denominator?
Is it
Numerator. So it'll be 2. If you ever rise you ever rise, the word rise, like the top, run on the bottom. I think rise is easier to remember because like, sunrise, whatever is on top. Here's the horizon. So that's 2. And the bottom here, it'll be 6. But you notice it's 1/3. However, where's the negative? How do you know it's negative? Let's pretend this is still okay, all right? How do you know it's negative?
if it was a negative, it would be going the other way.
Yes, there's different ways to actually figure out the negative and positive too. But first of all, you can see why G is not correct. But there's an easier way. I think you need to learn this for later in math, especially pre-calc and calculus. So this will help tremendously. Okay, watch this. Okay, try to learn this. I know. Hey, let me dig your brain a little bit. I want to kind of get your attention here. I think you understand that you want to be open-minded about this. Like you said, you learn from your teacher here, and then you have me. That means you have to be open-minded. You got to be flexible about your way of learning, not going to stick to one particular method or way. Now, sometimes you will have this only one method. There's only one way. But anything I say, it's going to be pretty much textbook based. Okay. And sometimes your teacher may not able to provide that. I'm sorry. I'm not saying he or she won't be able to do that, but sometimes we word it differently, or we may actually go, hey, instead of method 1, we do method 2, or vice versa. I'll try to cover as much as I can, but sometimes teacher tends to do it one way instead of another because of time constraint in class, things like that, right? So I understand that. But let's talk this way first, because it's actually easiest. I don't mean to criticize your teacher. Hey, your teacher didn't teach you the easy way, blah, blah, blah. Here, you still need to know this concept. It's huge in graphing. It's huge in later math. I believe you're actually going to get into like pretty fancy math later on. I think you might have mentioned that you're going to go into some engineering or science or math, right? Possibly because the level that you're in kind of dictates that in a way, because the teacher placed you in an accelerated course for a reason, right? Therefore, there's a potential there, something that you can do later on, like, compared to some other students, right? Okay, this is huge. When you look at a graph, you scan from left to right, just like reading a book. Left to right, 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 okay? So now, you have to think that every single time when you look at a graph. This is going to be a huge concept. These graphs are actually very straightforward, very easy. But later on, there will be curvy stuff on one graph, and you have to establish where it's increasing, decreasing, where's a max, where's a min. Okay, so this is why this is like the beginning of it. Okay, here we go. Let me ask you: when you scan from left to right for graph F, is it increasing or decreasing? The way you look at it, from left to right, is it increasing or decreasing? If you scan from left to right, is it going up or is it going down? Increasing is going up from left to right. Decreasing is going down. Is it going up or is it going down from left to right? For graph F.
It's going up.
Okay, so it's increasing.
Yeah.
Increasing, but a little bit slanted, right? A little bit, this is steeper. That means the increasing value is actually higher here compared to here. Now, H, is it decreasing or is it from left to right? It's decreasing, right? It's going down, right? From left to right. Think this, okay? This is going to save your butt later on too. So it's decreasing. This is also decreasing, but very steeply. Okay. Now, back to what I intended. If your slope is ever increasing, it will always be positive. Okay, makes sense, kind of, or associate that. Okay, therefore, these two are out of the question. They're increasing, therefore the slope are positive. Okay, get it?
Yeah.
If the slope, this is actually normally is taught in accelerated course, by the way. I think if you haven't heard this, your teacher may have overlooked it, or it's coming up later on. Okay, so far? So that means you can actually, ignore F and G for the slope being negative. So one of these is going to be the answer. Okay, from left to right. No kidding, just like that. The slope sign dictates how the graph looks also, okay? Besides just doing the math. Okay, now, all right, there's more to it too, but let's go ahead and now make an educated guess. Do you think it's H or J? And we'll prove it.
J.
Okay, it is J. Now, why? Because if you remember, now, right now, you can put the negative in front. Put a negative in front right now, because you just learned the concept of the sign being increasing, decreasing. We're talking about slope, okay? M, the slope. We're talking about the slope value, the two values here, okay? Okay, so the numerator, let me make it, I don't want that box. The numerator, so you're gonna rise. So let's pick a point. Okay, anyway, now there's more to it than this. The negative can happen when you're actually going down, okay? But let's ignore that concept because we already established the sign. So let's go ahead and rise like down 2, okay? That means it's 2 in the numerator. Is that okay? Then you're gonna run over 6, right? So it's 1/3, negative 1/3. Now, there's more. If you don't think about increasing or decreasing, Alex, if you don't think about increasing or decreasing, you'll get negative immediately without having to think negative, increasing or decreasing. However, it's easiest not to worry about the sign when you move, from when you actually rise and run. If you can think ahead, like the shortcut, right? Well, it's not really, I guess, but if you know it's going to be negative, then you go ahead and rise up or down this 2 and run over 6. Don't worry about it's negative or positive because the answer has to be negative right now. Okay, so right now it's negative 1/3. So anyway, this one, if I start here and I go and I rise, or I don't know, I can go over here and then run this way and go up, whatever, right? You've been forming a triangle even with your teacher and with me too. Okay, so 6 down this way, and then 1 over. So it's 6, 2. But don't worry about the sign. I'll go back and get the sign for you if you want to do math this based off your rise and run. Okay, the sign. Okay, there you go. The answer is going to be -3. So the answer is going to be J. Now, let's go ahead and now pretend you didn't actually remember decreasing, increasing. Take a look. Let's talk about it now. I did kind of go over it, but I don't intend you to remember every single detail because you have so much going on. Okay, here we go. The rise. If you pick a point here, oh, wait, no negative. You don't know the negative or positive yet. Pretend you forgot. Like
Yeah.
from left to right, decreasing, negative, increasing, positive, right? Let's say, go ahead, let's do it from scratch. You pick a point here. Now, I guess, I don't know. If you want to pick a point there, you can pick a point here. It doesn't matter. Which one do you want to do? You want to pick here?
Yeah.
Okay. The next one, we'll pick it here. Is that okay? Next one,
Yeah.
we'll pick it here. Let's start here. So I know you're going to form a triangle. So we're going to rise down. Remember, if you rise down, if you ever rise down from a point, it's a negative. So rise down too. At least this, I believe your teacher went over. I'm pretty sure.
Yeah.
Okay. And then you run over 6. If you go to the right, it's positive. So the only negative that you got is in the numerator, the rise. Okay. Therefore, the answer is -1/3. Now, what about over here? Okay. Let me go over here this way and then go up. Okay. Like I'm going this way and then I'll go up. So if I run, I'm going to form a triangle. I'm not going to rise yet. I'm going to run this way. If I run this way, I'm running it how many places? 2, right?
Yeah.
If you run to the left, it's -2. And if you go up, it's still positive 6. Therefore, it's going to be, again, -3. You see that? 6
Yeah.
divided by -2. Now, you can think that, but if you actually don't care for the, you don't want to remember, hey, was it 11 right, up and down? Which one is negative, whatever. The easiest way is look at the graph. If it's slanted downward from left to right, it's decreasing. Therefore, it's negative. All you need to form a triangle, the rise and run. Okay, get that? They're both decreasing. They're negative. So the different way to actually establish the sign. But right now, the fastest way to me, and likely should be to you for every student, if your teacher has taught you, would be the increasing and decrease concept. Okay. So anyway, I hope you got that. It will save your butt, or at least for checking purposes. How about that? If you can still rise and run with the sign, whatever, you can do however you remember it. But if you want to check your work, hey, you know what? I picked G, but the G, Tosh said that if it's going from left to right, it's going up. Oh, dude, I gotta go back and check my work. Therefore, you actually now not gonna pick G anymore because it's positive. Okay, at
Yeah.
least that. How about that? The different, there's different thing that you can actually take in. Okay, what about number 7? In 1996, hey, some of the stuff here, like the year, sometimes they're decoy, like years. Sometimes they give you 2 years. Like here it is. I'm sorry. No, I take that back. Sometimes not. It actually, like sometimes if they do talk about 2 years, you might have to subtract them and all that. But okay, anyway, ignore what I said. Because sometimes they do just try to be realistic. They tell you, hey, in this year, something happened, this many thing happened, but you never actually used the actual year
Yeah.
in your computation. Okay, so anyway, I just want to kind of point that out. If I think you understand that. Yeah. All right, let me see. In 1996, there were 171 area codes in the United States. In 2007, there were 215. Okay, find the rate of change from those 2 years. How do you do it? I know you were doing it here, I think, but what do you think? What is this the work right here? You can explain it to me from scratch.
So I did. So I did 215 minus 171.
Okay.
Go over there.
Mm-hmm. Like subtract it
40.
like this. Like, okay, I see that you did that. Okay, I'm gonna write it sideways, and then now what?
And then, so I divided 171 by 44.
One, 171 divided by. I I think you're actually looking at your own work here. You subtract and you get 44. Want to
Oh,
start from scratch?
yeah.
Want to start from scratch? Okay, maybe you shouldn't look at that work. Don't forget, like if you go over this stuff with me or on your own, you don't want to look at your own work. You want to pretend you simulate you being tested, like you're taking a test, right? So, all right, let's read this from scratch. Okay, I already did. This year there were this many error codes. The next later year, there's this many code. Find the rate of change. What does that mean? Now, you heard of it, but sometimes like, oh man, I forgot. But let's let's see it. Let's talk about it. I know how it's like kind of vague. Rate of change from this 2 years from this year to that year. What is that? What does that mean? Yeah, it's like something on top. Okay, here we go. I know you were doing the work here on the side, like with long division and all that, but if you recall the rate of change, right, the concept of that, or unit rate, or something along that line, right? With the
Yeah.
word rate, there's normally going to be something in the numerator divided by something in the denominator. There's normally going to be a unit, like a price, over an item or something, or, and it could be the other way around also, right? So that means
Yeah.
that's like that. It's like that. That means you want to kind of set up that fraction, okay? But I know that it's like, how am I supposed to know that, right? I know.
Yeah.
So let me help you. So rate of change, it's like something over something else, unit wise, like price over item, price per item, whatever. But this one is about something else. There's two units here. One is the area codes, changes in area codes, and then changes in year. There you go. See it? Like, I'm sorry, the area codes between these two here. The 215 and 171. And then there's a
Yeah.
change in the year. So therefore, yeah, this one could have been written better. Like, hey, find the rate of change. For example, here we go. Find the rate of change in area code area codes per year. Actually, that's what they want, but they didn't detail that, so it's not well written for sure. I'll say that for number 7, it's not well written. Had they give you that hint, the last part right here, right? Find the rate of change in area codes per year. That would be easier. Area codes per year. Therefore, it's implied that area codes in the numerator per, like division, right? Right? Remember, I think, or implied something similar to a year, like per, like the word per. So, but that's it. So let me set it up right here, right now. So anyway, it's like area codes. Yeah, they didn't write that part, so that's why you like you could do any math you want, like you did over here. So I'm good. I'm good. Yeah, you try to do whatever you can here, so I'm good here. So I understand it because it's not just you. There may be other students in your class who like no idea. So yeah, anyway, area code, the number of area codes, I guess, on top, area codes per year, over year. Now, it's likely going to have to be 1, unit rate. Yeah, rate of change. But let's do years for now, then we'll reduce it. Okay, anyway, area codes, so you did the subtraction. Looks like it's 44. Yes, it's 44. Okay, it's like 44 up on top. And the year, take a look, okay? The year, you should subtract the 217. Wait, make sure that you actually subtract. Okay, let me write it all out, okay? So I'll be subtracting 2, like the bigger one, 215 minus, let me intrude into the space here. So it's going to be 215. You can do this on the side, whatever, 171. But the bottom is will be, let me make sure, okay? The first year, the 215 relates to, 2007. So you have to make sure that's underneath it. 207 right here. Subtract, and this is going to be underneath the year 1996, underneath 171. So 196 here. Do you understand this? Okay, just kind of follow me on like that. You can do this on the side, wherever. You don't have to write it as a fraction if you don't want to. But if you want to do it like methodically, it'll be like that. Okay, so here we go. If I continue, what is that? Is it 44? Pretty sure. Like
Yeah.
using the calculator. Sorry. I'm not thinking. Double checking. Yeah, it is 44. Over, what about 2007? How far apart between them? That's what? How many years?
Um,
11 years. You
yeah.
can, however, you can count it. So the answer is not 44. It is 4. So it's 4 codes or area codes per year. If you reduce it, you want to see it? Sure you understand this? If you reduce this, 11 can go into 44 4 times itself 1 time. Therefore, it's 1 on the bottom now. Therefore, it's like year. The top is the 4 codes, area codes. There it is. This is the answer. Like area codes on top. So it's, in the end, it's 4 codes per year.
Yeah.
Okay, so it's going to be B, okay? You want to fix that.
Yeah.
Now, I understand it's not well written. Once again, had it given you the unit to do the math, you know, area codes per year, then that would at least give you the hint to do it. But no, they didn't. Yeah, it's not well written. But yeah, sorry, this is the way it is sometimes. Okay, that's it. Are you okay? I'm glad we went over this, and I can't wait for the next one. Okay. All right, we can call it early, unless you have something online, or you think you're okay. Do you have any?
Uh,
You okay? Do you have any other question for this particular review? Oh yeah, look at that, review number 1. It seems to imply there is more than one. Yeah, I don't see anything else that I showed you the horizontal line there, another variance of it, and yeah. So just be aware that's something that can be on the test. So wait, can I ask before we call it? Will there be the same concept, like all these concepts, on the next review, or there'll be something new entirely, something else that I don't remember what we've covered up to this point. Oh, I do remember some. I don't remember. Yeah, I remember all of these. The intercept concept, but
yeah.
there were no word problems until now. The slope I remember, and the arithmetic sequence, and linear functions, the graph. Yeah, we were doing online. Okay, the only thing I can think of for the next one is that they might actually have you work more on the graphs besides these one up here, and also relating to it, like the slope, maybe the equations, come up with the equation.
Yeah.
We worked on that online. That practice, is it Alec? Alec, I think. I don't
Yeah.
remember.
I
Yeah.
think it was out.
Yes. So if not, it will be another sets of these problems. More practice, more of it, more of these problems. Okay. All right.